Today we are talking about binary search. So this is a super cool search algorithm which you might be familiar with. But if you're not, here is a quick review of what it is. So the main concept is that you are given an array, okay, for example this, and you have to find a particular value, for example this. Okay, so here's the procedure. What you do is you split it into half and you kind of have the middle value, okay, and if your target k is less than the middle value, then so first you need to sort the array, obviously, okay. As you can see, this is a sorted array, so this method kind of only works on sorted arrays, so that's kind of important. Given an sorted array, okay, so if your k is less than the middle value, then you're only going to concern yourself with the remaining array to the left of the middle value. If it's more than that, then you're going to concern yourself with the array to the right. Okay, amazing. So that's what we're doing. If k is less than mid value, search lower half. If k is higher than mid value, search upper half. And if k is equal to the middle value, then return the middle value. Perfect. So what does this algorithm, the searching algorithm, it reduces the time complexity from n, which is the time complexity for your linear search, to log n, which is for your binary search. Okay, another thing is that we use recursion. Okay, so let's quickly learn how to do all of these things. Okay, awesome. So first of all, what we're going to do is that we are going to return over here itself our bin search. This is a function, this is a method, and it's gonna have nums 0, that is the lower value, then nums dot length -1, and it's gonna have your target. So this might not make sense, but first let's start with writing our method. Okay, so public static int, okay, it's going to return an integer. As you can see, the return type of this is int, and we directly wrote return this, so it's going to return int, and we are naming it bin search. You can name it anything, binary search or something. And what all is it going to take? It's going to take your sorted array, it's going to take the lower value, it's going to take the higher value, and this higher value is the last index, basically the first index, the lowest index, and the highest index. And we have our target. Okay, these are the four arguments that we are passing in this method. How are you going to start this? First of all, our condition is that if low is greater than high, if at any point that is true, we just want to stop. Okay, we want to return -1. Okay, it's like a mission abort sort of thing. Then we are going to define this variable called mid, and it's going to be low plus high minus low by 2. We're sort of taking the average of it. Okay, but make sure that you do this, okay, low, because we're going to pass this again and again, so you can't just keep say 0 plus high minus low by 2, right? Yeah, I guess that makes sense. Okay, you would generally do low plus high by 2, but this is another way of doing it, and we really need to look into why. Yeah, because if you do the math, it kind of is the same thing as low plus high by 2, but yeah, I'm sure there is something here. Anyways, going back to our thing, this is our int mid. Okay, once we have our mid, what do we want? We want to compare it with target. So if mid is, we are gonna first check for the lowercase. So if target is less than mid, then what do we want to do? We want to return. Okay, so this is where the recursion goes. Okay, we are returning the function itself. Okay, and this time we only want to concern ourselves with the lower half, as we said. So low mid -1. Okay, so that's the last index. So if 5 is your mid, okay, then mid -1 would be 3. Okay, so we're only checking that. So in this case, if we consider mid, okay, first low will be 0, 1 2 3 4 5 6, so this will be 5. So here it would be 0 plus 5 minus 0 by 2, so that is essentially 5 by 2, and that's kind of the same with the low plus high by 2. Okay, we'll definitely check this too. Anyways, without wasting further time, that this is a small detail, that why we write low plus high minus low by 2 and not this. Okay, we'll get back to that, but yeah, so we're checking the lower half, right? And of course we're going to pass target. Similarly, we are gonna say else if target is greater than mid, then let's check the upper half. So we're going to return bin search nums mid +1 and high and target. Cool. Oh my god. Okay, girl, what are you coding in Python? And else, which is the last case, that it is equal, then we are going to return ayo. Okay, we're gonna return what? We're gonna return mid. Awesome. So that's kind of cool. I think that covers all the cases. Yeah, and that's pretty much what we want to do. Okay, let's check our code. Okay, that's literally so terrible. Why? If low is greater than high, yeah, low, high, target. Okay, this looks good to me. Wait, where did I even go wrong? Is it always showing -1? Interesting. Oh, I think I get it. Here you're checking mid. You want to check nums mid. Remember that we are dealing with indexes. Okay, that is awesome. Okay, now let's check it. Amazing. Okay, that was such a bad error. Oh my god. Okay, so I hope you get it. Yeah. Okay, so it's nums mid. You're not check. We just said if it is less than mid, more than mid. So it's what is mid? Mid is your index in this case, right? So in this case, you should maybe name it as mid index. So you remember, you know, that this is our mid index. Okay, and you would change that everywhere. It would be easier in maybe VS Code or something. But yeah, cool. I think it's good to make these errors sometimes so that you remember that you have to wake up and pay attention. Yeah, but anyways, otherwise I hope you understood the main concept and this works. Also, let's do a little thing when we and check if this low plus high by 2 works, but we'll first submit the code. Awesome, so this is a good solution. Now let's check our thing. Okay, fingers crossed. And let's see if it affects it at all. I think it will affect it because, okay, it actually absolutely doesn't. Wow, how wrong could I be? So yeah, this also logically makes sense. Even that's another way of writing it. I've seen it being written a lot, so maybe we could get back to, you know, trying to understand why it's written like that. Anyways, that's it for now. I hope you understood. Thank you.